Hi geometry students. This video is on special right triangles. Specifically it's on 30, 60, 90 right triangles. So I'm just going to formalize the relationship that we saw in the exploration and then run through a couple of examples. So the idea is that we get a 30, 60, 90 right triangle when we split an equilateral triangle in half on its altitude. So we can kind of think about this as being half of an equilateral triangle, in which case this bottom angle, which is an original angle in the equilateral triangle, that's where the 60 degrees will happen. Then we have our 90-degree angle at the right angle and 30 degrees up top. So then the idea is we have three different sides. We have our hypotenuse, just like we do in the 45, 45, 90 triangle. But now, unlike the 45, 45, 90, the two legs here are different lengths. So I'm going to call the short one the short leg and the long one the long leg. And we should always kind of be able to tell when we look at a picture which one is the short one, which one's the long one, just visually which one is longer. So the relationships that we saw in the exploration were that if we call the short leg, say, x, then the hypotenuse is always 2 times that. So I'll write 2x. And then the long leg, the relationship we saw is that it was the short leg times the square root of 3. And I'm just going to write out to the right what this looks like in words, if words help you. And also, depending on what you're given, you can use a slightly different kind of formula to get to your unknowns. So the first one I'm going to give us is that we know for this statement here, we'll say the hypotenuse will equal 2 times the short leg. And the long leg is going to equal root 3 times the short leg. So both of these formulas we'll use if the side length you're given is the short leg. So the next formulas we'll use if we're given something else, okay? So if we're given the hypotenuse, we can use this formula to find the short leg. We'll say the short leg is equal to, so if I have the hypotenuse and I want the short leg, I take this and divide it by 2 to get rid of that 2 right there. So we'll say short leg is equal to hypotenuse divided by 2. And when are we using this? We're using this when we're given the hypotenuse. And then the last formula would be the short leg is equal to, now we're going to talk about, well, how do you get from the long leg to the short leg? You'd have to get rid of that root 3 that's being multiplied, so you divide this by root 3 to get the short leg. So we'll say short leg is equal to long leg divided by the square root of 3. And we'd use this one if I was given the long leg. So now let's look at some examples. So I wanted to color code this, so I'll go back. All right, so my first example, going to orient it a little bit differently, but it's still a 30, 60, 90 right triangle. And I'm going to start by giving, if I'm given the short leg as 3, then I'd like to find the long leg and the hypotenuse. So sometimes it's helpful, if it's helpful for you, you can kind of label, this is short, this is long, this is hypotenuse. and that just might help you kind of think about what you're going to use. So if I'm given the short leg, well, to find the hypotenuse, b, it's going to be short leg times 2, right? So I would do, and I'm getting that from essentially this formula, right? 2 times the short leg. Short times 2, same thing. So that would be 3 times 2, or 6. And then to get the long leg, I'm going to do the short leg times root 3, which would be 3 times root 3. And in general, like I always want to write the number being multiplied to a radical out front, just because it's very clear that this 3 outside is not inside the radical or inside the root. And that's my final answer. So it's as easy as that. So the next example is going to be, we're given the long leg. So I'm given that my long leg is 4 root 3, and then let's call the short leg A and the hypotenuse B. So again, it might be helpful for you to label them with what they are. So to find A, my short leg, well, I can kind of go back up here and see, well, if I'm given the long leg, to get my short leg, I'm going to divide it by root 3. So long leg divided by root 3. In this case, that's 4 root 3 divided by root 3. The root 3's will cancel, and I'm left with just 4 for my short leg. Now, if I want to find my hypotenuse, or B, well, I don't have a formula that plugs in straight from the long leg to the hypotenuse, but I do have 2 times the short leg is the hypotenuse, and I just found my short leg was 4. So we'll do short times 2, which is 4 times 2, which is 8, to get my hypotenuse. And I'm going to do one last example. And in the third example, we're given the hypotenuse and we're trying to find the 2 sides. So again, this is the hypotenuse. I'm looking at these 2 sides. I know this is the short side and this is the long leg. So now I can kind of reference my formulas, and I know that the short leg is the hypotenuse divided by 2. So it should be short, which is A, is hypotenuse divided by 2. In this case, that's 10 divided by 2, which is 5. And then to get the long leg, I'm going to take my short leg and multiply it by root 3. So we get 5 times the square root of 3 as my value for B. Now I'm just going to draw some U-try problems at the bottom. So for each of these U-try problems, you need to find the 2 side lengths that you're not given. And each of them corresponds to one of the examples. So think about what information you're given, and then what formulas are you going to need to follow. So here's the first one. I'm just going to zoom in for y'all. Second one. And that's the last one. So you're responsible for trying out each of these and finding A and B in each.